All right, we're taking a look at some of the triangle proofs from your Delta Math. Let's see what they gave us. They told us that AE is congruent to EB, so that's these right here. That makes this an isosceles triangle. And then DAE is congruent to CBE, so DAE, okay, that's that top, the green angle. CBE, that's the green angle over here. And then they want us to say, why is EAB, yep, congruent to EBA? Well, because they gave us that these lengths are congruent, that makes this an isosceles triangle. So let's see if two angles, there we go. In a triangle, angles opposite of congruent sides are congruent. All right, then they're saying that DAB would be congruent to CBA. Okay, let's see. There we go. Congruent angles added to congruent angles form congruent angles. Then they want us to say, why is DEA congruent to CEB? Those are vertical angles. So let's see. Okay. So now we can say that DEA is congruent to CEB because, take a look here, we have an angle, a side, and an angle. Angle, side, angle. So we will say angle, side, angle. Then the last thing they wanted us to prove, DA is congruent to CB because CP, CTC. Then AB would be congruent to AB because of the reflexive property. So now we know that DAB is congruent to CBA. What would our reasoning be there? Well, we've got all three sides actually. We've got we don't have this top section. Good. We have a side, an angle, and a side. See how we did. Good to go. All right, let's try another one. Okay, we are trying to prove that ABC, so the big triangle, we're trying to prove that it's isosceles. All right, so they gave us some information. BE is congruent to BD, and ABE is congruent to CBD. So why is BED congruent to BED? Well, those are the base angles of an isosceles triangle, which their statement was if two angles, something about being opposite the sides. Angles opposite of congruent sides. There we go. In a triangle, angles opposite of congruent sides are congruent. BEA, and BED are supplementary. They form a straight line. If two angles form a linear pair, they are supplementary. BDC and BDE, those also form a straight line. If two angles form a linear pair, they are supplementary. So that means that BEA must be congruent to BDC because if two angles are supplements of the same angle, then they're going to be congruent. So because BEA is supplementary with BED, we know BED is congruent to BDE. And then because these two are supplementary, they must be the same. All right, so that means that AEB is congruent to CDB. We have angle, side, angle, angle, side, angle. So that means that AB and BC must be congruent because of CPCTC. Corresponding parts of congruent triangles are congruent. All right, now we must know that ABC is an isosceles triangle because the triangle has two congruent sides. We are good to go. All right, let's try one more of these. Okay, BD bisects ABC. So that means it's cutting it in half. And AB is congruent to CB. Okay, we can see that. So BD is going to be congruent to itself by the reflexive property. ABD and CBD. Remember they told us that this angle is being cut in half. So we are looking for something about an angle bisector. An angle bisector divides an angle into two congruent angles. So then ABD would be congruent to CBD by side, angle, side, side, angle, side. So now we know that AD must be congruent to CD because of CPC, PC. Good to go. All right, let me know if you have more questions from this section.